Hi out there! Today I'm coming up with a modification where I think a lot of ham radio operators are waiting for. Here today on my bench is the IC-7100 from ICOM. And you may have heard that this radio has some problems with SSB Power. So maybe you have already read all the complaints on the internet that you only read 60 or 70 watt output on PEP, and as far as I've heard, there are some comments that on average you read only 20 or so. So that means basically you are not able to get full power out of this radio. And today I want to show you a modification on the ALC amplifier to bring this radio up to full power. Okay, so let's go to the bench and let's see what we can do on this nice ICOM. Okay, and here's the 7100 right on the bench, and let's see what we see on our power meter when we switch it on and we try to do transmission, and then we see is it really what we have been told. Okay, and RF power is set to 100%, so that means PEP should be 100 watt, and mic gain is at 75%, so we can play a little bit with the mic gain to see if it makes any changes, because there are also some reports on the internet telling that you simply need another microphone to get rid of this problem. So yeah, let's see what we can influence with our mic gain. Okay, so let's check what we can get out of this radio. 1 2 1 2, check check check. Hola, check 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 check. 1 1 2 1 2 1 2 1 2, check 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 check. 1 2 1 2 1 2, check check check. Yeah, you see, we can really force it only to get up to, what was it, below 70 watt PEP. So that is a peak hold for the moment in time. Check 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 check. 1 2, check check check. Yeah, 70. 1 2 1 2, check 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 check. Yeah, but when I'm only talking, you see it might be in the peaks around 70 watt. So it seems that we are not really able to get it really pushed up to 100 watt. Okay, so let me simply try to increase the mic gain. So now mic gain is at 100%. So let me check what this does. 1 2 1 2. So not really a change. So let me. I reduce it right now, and I'm at 37% for the moment in time. And 1 2 1 2. So that really does not make a huge difference. So back to 100, and you see that we are not really able to get it to push it, over. Yeah, here one peak is at 75 watt, but normally we really should see a peak which is simply going up to 100 watt PEP, but there is really nothing. Okay, I will switch it to average. I mean, normally average testing is senseless for SSB, but as we had some videos, not videos, sorry, some comments on the internet that on average the reading is somewhat around 25 or so. So let's see. 1 2 1 2 1 2, yeah, 26. 1 2 1 2. Hola, audio. Yeah, you see best case 25, 26 watt average, and here in fast attack mode 1 2 1 2 1 2 1 2 1 2. Yeah, we really can do what we want, so we are really ending up with only, yeah, let me say best case 70 watt PEP, and that's it. 1 2 1 2 1 2. Check audio. Yeah, maybe 75 in the peaks. Yeah, let's see if we can change this to over 100 watt. Yeah, and let me show you what we are going to do. So this is a PA unit, and we have, yeah, with all radios, we have just in front of the antenna output, we have our power detector, and this detector is reading the forward power and the reflected power. Both is needed, so if we have a bad antenna connected to our radio, then the high reflected power from this amp here will reduce the output power, not to damage our radio, and this forward power is needed for our ALC amplifier to adjust the output power to what we want to. Yeah, and here we are on the main board, and you see here is at least our ALC amp, and well, this all works with the power coming here from our power detector, from the power amplifier, and here we have our POCV input, which is, as you like, the information coming from our processor and setting the wanted output power. If now there is the power coming back from the power detector overdriving the preset here at our POCV input, then this comparator will give an ALC voltage here to, let me see, can you see it, right, to our IF amp. So this is the IF amp in transmit, and you see here the ALC input, and yeah, this will then reduce the IF amplifier output gain just to reduce our output power at our output terminal. And if then the output power is too low, then of course when we go back here to our ALC amplifier or comparator, then of course this will switch again and tell the IF amp to increase the output power again. So that is how it is basically working. Okay, and this here is really our schematic, and this here is our ALC amp, and you can see it. Can you see it? Let me see. Yeah, this here is our ALC output line, and this is the ALC comparator or ALC amp, whatever you want to call it, and you find here our POCV, which is the pre-adjusted level from our microprocessor, and you see here our forward power coming from our power detector. And what we are doing right now is very simple. We make this comparator a little bit slower, and that is simple. We add here a little capacitor. So we put here a little electrolytic capacitor value of 10 microfarad to the input here coming from our power detector, and that makes the ALC slower, that not every peak will directly switch this comparator and tells the IF amplifier, hey, reduce your power, there is too much power at the output. And that will do a little capacitor, because then it all gets a little bit slower. And what we do as well, we bridge this transistor here. Can you see it? Yes. Huh? Or not? Yeah, you can see it. So we bridge this transistor, because normally this transistor is only working on AM. So we bridge it, and then we have this. This is a kind of low pass filtering. And yeah, if we have a very, very strong peak, you know, if you have a peak there, you have a lot of high frequencies, and these high frequencies will be reduced by this low pass filter, and that will help as well to make it all a little bit slower. And then we should be really able to get our full power as we want to see it. So that is a modification we are going to do. So far our theory on what we are doing, and now let's have a look into the radio. Let us crack it open and go to the point where we really have to add this capacitor here, and of course this bridge here over this transistor. Alright, and this here is the board where we need to add our capacitor, and yeah, have a look. This is a capacitor we want to add to this circuit down here, and yeah, at the moment of time we are a little bit lost. So yeah, let us have a look into the schematic, that we find the points where we need to solder this big boy here. Okay, and here we have our schematic once again, and yeah, here we have already our orientation, so we know the capacitor has to go here over the R1522, so that means capacitor right over here, and we know that we want to have a bridge here over this transistor, so that is the second connection we need to do. And yeah, when we move over here to our PCB plan, then what we can find here, this here is our C1508, and we need a bridge from here to can you see it? Hang on a second. Yeah, we need to get a bridge from here to there. So this is a ground point. So bridge is from here to there. And yeah, here, this little resistor, this guy is our R1522. So this is a resistor where we need to get our capacitor over. So that is what we need to do. And well, here on our PCB plan, it looks, yeah, all nice and easy, but yeah, let us go back to our original circuit. Alright, and we are back on the PCB right now, and yeah, so our ground point, which we have seen in on the PCB plan, was here, and yeah, the little capacitor, the C1508, is this guy here. So what we need to do is a bridge from here to there, and the resistor where we need to put our capacitor over is, oh, I can't really see it here from my position behind the camera, but it must be, let me zoom in, maybe that I will be able to see it when, now it already gets out of focus. Alright, so it is really so tiny, it is so tiny. Now the magnification here through my camera is bigger or greater than what I have on the PCB, and this here, this little fly shit that is really where we need to get our capacitor over. It is really so tiny, and now see this big component. This is our 10 microfarad capacitor, which we really need to get, and you might see what it means. We really need to solder it to this little resistor. Ridiculous. Okay, so let's go for it. Let me prepare it, and then let's try. Yeah, and just to show you the situation here, be really careful. We have really tiny components, and yeah, it is really nothing for beginners. So if you need to get this modification, bring your radio into a radio shop, or you are really experienced, then you can of course do it by your own. Right, we are now a little bit closer, and you see what we have done. So we have, where is it? I can't find it here. Here we have our bridge, and here is the new capacitor placed between this little resistors down here and ground. Yeah, and of course this is my first brand. It is the Panasonic FC series, and you know I love this Panasonic capacitors, so of course this is in here as well. So work is done, and yeah, I just zoom out a little bit just to give you again the situation on board, and you might be really able to see how small and tiny this is all here on this PCB. Okay, so let me put back the housing to this radio, and yeah, then we can check if this modification does a difference. Okay, so all is back as it should, and yeah, let's do our test if we were successful or not. And yeah, here we are with the radio, and yeah, mic gain, RF power 100%, so that is full power. And let's see what we have, what our difference is. Alright, and first of all I've set it to average, because we have seen that it was yeah, on 25 watts or so before, and some internet posts I have seen, there was mentioned that after this modification we have approximately 60 or so. So let us first have a look on average. 1 2 1 2 1 2 1 2, check 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 check, 1 2, audio. Wow, awesome, awesome. So I've seen it goes up to 80 or so. Awesome. Okay, let's switch it to peak hold. Now we are PP, and yeah, let me talk very, yeah, not too loud. So let me simply talk normal. Would you call it like that? Let me talk normal. Okay, so 1 2 3. Hello, this is the radio after the modification, and what you see, we have now 139. It was 135 right now, and you see it is always peaking. It is always peaking 100, and let me wait. All right, and you see easily it really powers easily over 100 watt PEP, and now you have really full power available. So let me go over here to the radio, and you see we have here 100. Let me go back to, let me say 50 on mic gain, and let's see if it makes a difference. Yeah, not really, but let me switch it to fast attack, then we can really see it a little bit better. Yeah, you really see it is easily going up over 100 watt PEP, and that means, and I'm really not talking very loud, so that is quite normal yeah, speech, what you would do when you have a normal QSO. So everything seems really to be good. Yeah, that means for me modification was really successful, and that modification really makes sense. So easily making the ELC really slower with this little capacitor, and you see it is really working fine. Alright, and that means we are already at the end of this video, at the end of this modification, and as you've seen, it really makes sense, and I hope that will help all the ICOM IC-7100 owners, so that they really get the punch they need, especially when they are mobile on the road. So that is the modification you can perform on your radio, and you will be happy, hopefully. Okay, if this video made any sense for you, and as always, please give me a big thumb up, and yeah, catch you next time. Bye.